All right, gang, so we're going to dive into transformations, chapter 2.5, day 1 and day 2. Go over these with you and take a look at these goals. We're going to look at graphing functions with the horizontal and vertical shift. Remember, horizontal is side to side, vertical is up and down. We're going to look at functions using reflections over the x-axis or y-axis. And then goal number 3, we're going to use compressions and stretches, and we'll focus on the ones that we need to see today. Okay? So the first thing is we have the library of functions. And the big thing here is I have y equals x squared. We probably know what that is. That one is a parabola. So I have y equals a times the quantity x minus b quantity squared plus c. And you'll see all these are the same, but they have different things. Like this one has the absolute value. Okay. Well, we know what the absolute value one looks like. It looks like the v for victory. Okay, and the next one is the cubic function. Remember, that's the S curve, staying alive graph. Okay, going up to the right and down to the left. And the last one is the square root function. It's like a parabola on its side. It goes to the right. All right, so that's what our family of functions look like. So again, squared, absolute value, cubic function, and the square root function. Now we're going to do some different things here. We have different shifts. The shift that moves it up and down, the vertical shift, that's the C value. So that's the number that's outside of either parentheses, absolute values, or square roots. That's the number that's all by itself. So for example, if I see y equals x squared plus 2, I know that one is going up. Positive C goes up. And then if I see something like this, if I have y equals x squared minus 2, then I know it's going down. Okay? So I always say it is what it is. Positive goes up and negative goes down. Now the horizontal shift, that's the b value. So for example, if I have an absolute value function, I have the absolute value of x minus 3. Or if I have y equals the absolute value of x plus 3. This one actually does opposite of what you see. So if you see x minus 3, this one actually goes to the right. And if you see x plus 3, because it's minus, this is really x minus negative 3. This one goes to the left. So I always say opposite of what you see in parentheses, absolute values, or square roots. Positive goes right, positive goes left, and negative goes to the right. Okay. The next thing is the vertical stretching. If I have the a value, the number in front, if that's greater than 1, then that's going to be a vertical stretch. Okay, so what happens is you take a parabola, and if your a value is 2 or 4 or 6, it's going to get stretched up, and now it's going to look thinner. Okay, it's getting stretched, it's getting compressed horizontally, which means it's getting stretched vertically. Okay. If a is ever a fraction, then that's going to be a horizontal stretch. So if a is like 1/2, normally it looks like this. If it's 1/2, it's going to be wider. So it's going to stretch this way. Okay. Last but not least is the reflections. So the ones that we're going to see is, again, the a value. Okay. Normally, if a is greater than 0, it's positive. So it's going to look normal. So if it's a parabola, it's going to be a smiley face. But if a is ever negative, if a is less than 0, then you'll actually see it flip upside down, or flip over the x-axis, or flip vertically, and it'll be a frowny face. Okay, and that'll be an x-axis reflection, and we'll see what that looks like. Okay, so we're going to kind of walk you guys through a few of these examples and kind of show you how you can do it. Okay. First thing I'm going to do is I'm going to graph what I call the parent function. I see I've got, number one, I've got y equals x squared plus 4. Well, I'm going to graph what we learned in the library of functions. I'm going to graph y equals x squared. Okay? So if I remember, 0, 0 is my vertex. I go over 1, up 1. So 1 squared is 1. If I plug in 2, 2 squared, 1, 2 is 4. So over 2, up 4. 1, 2, 3, 4. So I got 0, 0. If I plug in 1, I get 1. If I plug in 2, I get 1, 2, 3. Oh, I'm off 1. There we go. And if I plug in -1, I get 1. And if I plug in -2, I get 4, like that. Okay, so this is the parent function. So this is what the graph looks like. That's a nice, pretty parabola. Okay, well now I have a C value. And that C value is positive, so it's going up. So all this graph is shifting up 4 units. So I'm going to take this guy at 0, 0. I'm going to count up 1, 2, 3, and 4. Okay, so my new vertex was at 0, 0. It's gone up to 0, 4. This guy right here at 1, 1, I count up 1, 2, 3, 4. This one right here, count up 1, 2, 3, 4. And everything gets shifted up 4 units. And that's my new graph. Okay? You don't have to do the parent function. It just helps you visualize on what's going. So this whole graph got shifted up 4 units. Okay. All right, let's take a look at the next one. The next one, I got an absolute value function. Okay. So I like to graph f of x equals, or in our case, y equals the absolute value of x. I like to do that one first. So if I plug in 0, I get 0. If I plug in 1, I get 1. If I plug in 2, I get 2. And again, this just looks like that. If I plug in -1, the absolute value of -1 is 1. If I plug in -2, I get +2, and it just looks like that. The dotted or dashed line, I'll go ahead and connect the dots here for this one. That's the parent function. Well, I don't want the parent function. I want this guy with the transformation. Now that one is on the inside. That's a b value. Okay, so we go back. Okay, if I see y equals x plus 3, this is really x minus a -2 here. So I see x plus 2, that's really x minus -2. That is a shift to the left. So I'm going to take this guy, 0, 0. My vertex was at 0, 0. Now I'm going to shift it over 1, 2. And I'm going to graph everything 1, 2. 1, 2. Basically, everything is getting shifted 2 units. This guy goes 1, 2, right there. 1, 2, 1, 2. Now everything has been shifted 2 units to the left. Okay, so my new vertex was at 0, 0. It is now at -2, 0. Okay, so all I'm doing is I'm taking that parent function and I'm moving it over. Okay, in this case, I'm moving it to the left. We always say opposite of what you see in parentheses, absolute values or square roots. Okay, so let's put it together. Let's go on the back side. Okay. So now this time I have a cubic function. So I'm going to graph y equals x to the third first. Okay, so if I plug in 0, I get 0. If I plug in 1, 1 cubed is 1. If I plug in 2, 2 cubed, 2 times 2 times 2 is over 2 up 8 units. And then over 1, down 1, -1 cubed is -1, and -2 cubed is -8. So it looks like this, a little S curve like that. Okay, that's the parent function. Now I want to take a look at what we got. First thing I see is I have a C value. So the number in the back is going up or down. If it's negative, it's going down. And the number here is your B value. That's going left or right. If it's positive, it's going left. That's really x minus -3. So I'm going to count over 1, 2, 3, and then down 2, 1, 2. So my new vertex, it was at 0, 0, and now it's gone over 3, down 2. So -3, -2. Okay? And now I can take all these points and shift them over to 1, 2, 3, and down 2. Move this point, 1, 2, 3, and down 2. Okay? Now I got my nice little S curve. Move all those points. It gives you an idea what it looks like. Okay. All right, so that's when we have shifts both vertically and horizontally. Now I take a look at the next one. Now I've got y equals 2x squared. So if I cover up the 2, I just have the parent function y equals x squared. Okay. If I plug in 0, I get 0. If I plug in 1, I get 1. If I plug in 2, I got 4. So I always go over 1, up 1, over 2, up 4. When I have a quadratic, it just makes it easy to graph. So now I got my parabola. Okay. Well, now this time I've got an a value. I've got a equal 2. Okay. We talked a little bit about this in the beginning. This is a stretch vertically. So this a value is now stretching my graph vertically. So if I plug in 0, I get 0. If I plug in 1 here, 1 squared is 1 times 2 is 2. So if I plug in 1, it goes all the way up to 2. Okay? Normally I go over 1, up 1. Well, now it's getting stretched by a factor of 2. I'm multiplying by 2. Next one, if I plug in 2, 2 squared is 4, and 4 times 2 is 8. So over 2 up 8. There's 4, 5, 6, 7, 8 right there. Okay. So I have the corner point here, 2 comma 1, and I have, 1 comma 2 and 2 comma 8. It's symmetric to the y-axis, and now I have a nice, pretty graph. Okay, if I look at the normal graph, it's over 1, up 1. Well, now it's over 1, up 1 times 2 is 2 boxes. Normally it's over 2, up 4. Well, now it's over 2, up 4 times 2 is 8 boxes. So that's the idea. That guy's been stretched by a factor. Okay, vertex still stays the same. The vertex hasn't moved. It's still at 0, 0. It's all the other guys that are getting. All right, last but not least, I've got this guy right here. Okay, so I got that square root function. Now it's hard to tell. There is a negative in front, so be careful. That is negative square root of x minus 3. So I'm going to graph this guy first, the square root of x. Okay, so I'm going to do that first. So if I plug in 0, I get 0. If I plug in 1, the square root of 1 is 1, so over 1, up 1. And then the next nicest square root would be 4. So I'm going to count over 4, the square root of 4. 1, 2, 3, 4. The square root of 4 is only 2. So the square root of 4 is 2. And if I wanted to, I could do the square root of 9. The square root of 9 is 3. So I get a nice looking graph here. Okay. Well, I got a couple things I got to do. I've got an a value right here. That is an a value that's -1. Remember, that's a reflection, or I call a flip. Okay. So this whole graph is going to flip down over that x-axis. And then I have a shift. This is a shift. That's a shift to the right. Now, it doesn't really matter which one you do first, just as long as you do them. So let's do the shift to the right 3. That'll be pretty easy. 1, 2, 3. And then over 1, up 1. Move all these over, all these 1, 2, 3. And that's what that shift looks like. And now this guy right here is a reflection over. So this gets reflected over the x-axis, just down 1. And this guy gets reflected down also. It's 1, 2, 3, 4, down 2. We get a nice looking graph now. Okay. So my vertex has now been shifted over 3 units. My vertex is now at 3, 0. Okay. Ladies and gentlemen, that is it for the first part, and we'll dive into the next part. Okay, gang, so we have the last thing is chapter 2.5, notes day 2. I've got 2 quick examples I want to show you. And this, ladies and gentlemen, is all about quadratics, all about the square function, all about parabolas, okay? So when we're looking at this one right here, our goal is to make it look like this up here. Okay, do you see this guy? So let me bring this down a little bit. We want to make this y equals x squared plus 2x look like this guy. If we can do that, then we know from our previous lesson, we'll know what the shifts are, up or down, from the c value. We'll know the shift left or right, and then we'll know our a value if there's a reflection or not. Okay, the ones you're going to deal with have no reflections or stretches, so you don't have to worry about A. It's really knowing where B and C is going. Okay, so if you remember, to get a quantity squared, we are going to complete the square. And I warned you, in the last chapter, it just doesn't disappear. Okay, we got to be able to do this over and over. It kind of makes its way back into all of our notes for every chapter. So this is what I'm going to do. I'm going to rewrite it, leave some room. I got y equals, and I've got x squared plus 2x. Okay, and we're going to complete the square by taking our b value, dividing by 2, and squaring it. Now remember, b is the number in front of x. So I'm going to take 2. I'm going to divide by 2, and I'm going to square it. So we know 2 divided by 2 is 1, and 1 squared is 1. Okay? So I'm going to take that 1, I'm going to add it to both sides. So I'm going to add 1 over here. Whoa! Again, we talked about, if we add 1 to one side, we got to add it to the other side to keep it equal. So if I add it over there, I've got to add it over here. Okay? So now I've got y plus 1 equals this. Well, we can factor this. So let's factor. Factors of x squared are x and x. Factors of 1 that add up to 2 are plus 1 and plus 1. Now I usually go right to this step, x plus 1 quantity squared. Okay? Now the last step, go ahead and subtract the 1 over. So I get y equals x plus 1 quantity squared minus 1. Right? So we graph it. Okay? We should know the parent function looks like this, y equals x squared. We know this guy is 0, 0. If I plug in 1, I get 1. If I plug in 2, I get 4. 2, 3, 4. Don't have to do the parent function. It just helps you guys visualize that it's a parabola. Okay? And now I got some shifts. The first thing we got is a c value. That's a shift down. And then I have x plus 1. That's a shift opposite of what you see in parentheses. That's a shift to the left. So my vertex is right here. I have a shift down and a shift to the left. So my vertex, my new vertex, is now -1, -1. So now everything goes over 1, down 1, over 1, down 1, over 1, down 1. All these points, over 1, down 1. So that's one way to graph it. The other way is, once you have your vertex, I just follow that pattern, over 1, up 1, over 2, up 4, because 1 squared is 1 and 2 squared is 4. It's just following what a quadratic would do. So there's my graph, just like that. Okay. The nice thing is, if I ever want to check this, just to verify that I've got it right, I can always use my graphing calculator. I can type in my original function. I had x squared plus 2x. Zoom 6, zoom standard. And now I take a look at my graph and I look at what I have here, and I can even double check my vertex. Second trace value, plug in -1. I got -1, plug in 0. I got 0, so I have that graph. I have those points. Looks perfect. Okay. So let's try it one more time. What do you do when you have a C value here? Okay. So for me, again, f of x is the same thing as y. I'll subtract that over. So I subtract the 2 over, so f of x, or y equals, same thing. I got y minus 2, leave some room, and now I've got x squared plus 4x. I'm going to take my b. I'm going to take my b, divide by 2, and square it. I'm going to take 4, divide by 2, and square it. So 4 divided by 2 is 2. 2 squared is 4. Whoa! If you add it to one side, you got to add it to the other. So I've added the 4 to both sides. Okay, and I simplify. This is -2 plus 4 is plus 2. And then I factor on this side. Factors the 4 that add up to 4, or x plus 2 and x plus 2, or I always go right to x plus 2 quantity squared. Last step is subtract that guy over. So now I've got the y all by itself, and now I have a perfect quadratic with my vertical and horizontal shifts. Okay, so if I'm doing this without the parent function, I know this is a shift to the left and a shift down. So I start at 0, 0. I'm going to go over to left 2 and down 2, 1, 2. That's my new vertex. So my vertex is at -2, -2. And now I follow the pattern of a quadratic. It's over 1 from the vertex, up 1. Over 1, up 1. Over 2, up 4, because 2 squared is 4. So 1, 2, and then up 1, 2, 3, 4. Over 1, 2, and then up 1, 2, 3, 4. Now I got a nice, pretty parabola. Okay. So, ladies and gentlemen, those are the toughies. Okay, guaranteed to see that on a quiz or test. Okay, and we'll have a test coming up in another few days here. Okay, ladies and gentlemen, you have a great day. Let me know if you have questions on this. Email me.